All right, go ahead when you're ready.
Good afternoon, my name is Jessica Ross and I'm from Sterling Heights High School.
I'm Seth Clark from Fraser High School, and this is the Pythagorean theorem. Oh, I don't have. And what we'll be covering here today is math content 8.G.B6, which is explaining the proof of the Pythagorean theorem, .B7, which is determining the length of a right triangle in the second and third dimensions, and B8, which is using the Pythagorean theorem to find distances on the coordinate plane. And the 8 stands for the grade, which is 8th grade. G stands for geometry, and B8 is the section and unit, which will be found in. And what is the Pythagorean theorem? The Pythagorean theorem states that in a right triangle, the square of A plus the square of B is the square of C. A squared B squared plus equals C squared. And proof of the Pythagorean theorem actually existing is using it to find the area of the yellow square, which is C times C, and each of the triangles is A equals 1/2 times base times height, and adding it all together is 4 times 1/2 times base times height is 2 times base times height, and adding the tilted square to the triangles is A plus B times A plus B equals C squared plus 2AB. And adding the area of the whole square all together is A times A plus B times A plus B equals C squared plus 2AB. And following that down gives you A squared plus 2AB plus BC equals C squared plus 2AB. Subtracting 2AB from both sides gives you A squared plus B squared equals C squared, and all that remains is the Pythagorean theorem. There are many other proofs to show that the Pythagorean theorem actually exists, and this is only one. And attention checker. What is Pythagorean theorem equation? Aaron.
A squared plus B squared equals C squared.
Correct. Good job, Aaron.
Now to use the Pythagorean theorem, given two legs of a right triangle. Here we are given leg A and B. Leg A equals 6, leg B equals 8, and we can plug that into A squared plus B squared equals C squared. And we get 6 squared plus 8 squared equals C squared. And when we simplify that, we would get 100 equals C squared. Taking the square root of both sides, we would get a 10 equals C, which is the hypotenuse. Now, similar to the other what we just did, instead of giving both legs, we are going to be given the leg and the hypotenuse, and we're trying to find the leg. Now we are given 4 equals A, B is unknown, and the hypotenuse is 16. When we plug that in, we get 4 squared plus B squared equals 16 squared. And when we simplify that, it would be, we would get B squared equals 48, and then we would take the square root of both sides, which would give you B to be about 6.98.
Attention checker. Find C. Liz.
C equals 10.
Let's find out. C equals 10. Good job.
Here.
Now, the Pythagorean theorem can only be used with a right triangle, and we were going to prove that by using the Pythagorean theorem on an obtuse triangle. Now we are given all the legs, and we are going to plug that in to get 8 squared plus 7 squared equals 12 squared. And when we simplify that out, we get 64 plus 49 equals 144, which would get you 133 equals 144, which is not true, so the Pythagorean theorem does not work with obtuse angles and only right triangles. Oh, this is the video. Can I go to YouTube and search it up real quick so I can pull it?
Sure.
So now if you are given 2 coordinate points on a coordinate plane, to find the distance, we could just draw a line to the 2 points which would connect them. And now we would need a perpendicular line down here since it has to be a 90-degree angle. And next we would just connect these 2 points to form a right triangle. And now over here, we can see that it's 4 units. Over here, it's 3 units because it's on the coordinate plane. And then over here, it's given that it's 4 units. And now, using the Pythagorean theorem, a squared plus b squared equals c squared. A equals 3, and b equals 4. And c, we are trying to find which is the hypotenuse and is unknown. So we are going to plug 3 and 4 into the Pythagorean theorem, which would give us 3 squared plus 4 squared equals c squared. And then we simplify that down to get 9 plus 16 equals c squared. And then simplifying that even more, we would get 25 equals c squared, which would then give us, we would have to take the square root of both sides, and then that would simplify to 5. And then c would equal 5.
Perimeters and Pythagorean theorem. The Pythagorean can be used to find perimeters of objects such as this right triangular garden basket. And using the Pythagorean theorem to plug in the corresponding sides, you get 5 squared plus b squared equals 13 square inches, of course. And getting that down more, you have 25 inches plus b squared equals 169 inches. And square rooting both of those down, you get b equals 12 inches. And now, since you have b, you can find the perimeter of your right triangular garden basket, which is 30 inches all around.
Now, let's say you wanted to build a zip line, and you were given a right triangle, but you didn't know how long you needed the rope to be. You could use a squared plus b squared equals c squared and plug in 50 squared plus 20 squared equals c squared to find the length of c. And when you simplify that, it would come out to 2,500 plus 400 equals c squared, which would then take the square root of both sides after you add 2,500 and 400. And then that would give you c to equal about 53.85 centimeters.
Meters.
Oh, meters.
All right, and a recap of what we went over today is the Pythagorean theorem equation is a squared plus b squared equals c squared. It can only be used in right triangles and is used to find the length of a right triangle's side when given the other 2 sides. Any questions? Time for a quiz. What type of triangle does the Pythagorean theorem apply to? So Lisa.
A right triangle.
Good job, correct.
Now, what is the Pythagorean theorem used to find? Yeah.
A missing side length or the hypotenuse.
The length of a right triangle,
Yeah.
yes. Which side is the hypotenuse of this triangle? Ooh, that was just Steven.
It would be C, the angled side.
This one?
Yeah. Oh, but it's trying to be?
That is.
I could do an arrow.
It's blue. It's right there. It's blue. Alright, now find A. John. Let's find out. It is 3. Good job. And these are our citations used in the presentation. And thank you for having us.
Did I just see the black screen of death?
No.
Yes.
Yes.
That was a black screen.
That was just a black
That's a black screen.
PowerPoint
I just
screen.
put
The black screen of
made
death?
black.
And then if you wait, that's how you
Yes,
Not
that's
check.
the amount that, yeah.
Yeah. Just wanted to look like. Go ahead, we gotta give you your comments. Okay. Okay, so just kind of
Daniela, just ignore us, okay? Because I know you're jumping up because you're next, but that's totally fine. So again, I know that I'm sounding like a broken record, but I see so much potential when I see you guys present because I know that you're going to be awesome by the end of this year. But with more practice, you would have known that and you wouldn't have been looking at that screen as much because when you scanned the crowd, you both were awesome. Like totally awesome. If we can just get that going all the time, that's what we're looking for at MMS2C. All right? You both look awesome and you both have potential to be the best presenters ever for the science presentation in about 3 months. All right, so keep that in mind. Have your presentations done early for your science ones, and I want you practicing a week before. All right, a week before everything completely done, just practice time. All right,
Okay.
that's how good I think you're gonna be. All right, so go ahead.
Cool. So for me, I think you guys both look very professional. So excellent job there. I missed the hook. What was your hook?
We didn't have a hook.
Okay.
My charming personality.
How's that working for you?
You guys not entertained?
I was totally
Sorry. Is this still on or no?
Oh, we can shut this off.